Today we will discuss some more problems of moment of inertia of composite figures. So now this is a problem. Find Ixx and Iyy for the given L section about centroidal axis. So this is a L section. For this side is 60 millimeter and this is 100 millimeter and thickness is 10 millimeter and here is also 10 millimeter. So now first of all we will find the centroidal axis, and to find that we have to calculate the centroid of this figure. So first of all we will decide these are the reference lines along x-axis and this one is along y-axis. So now we will find the centroid. So we divide this as in two parts. This is first part and this is second part. So we divide this like this. This is first part and this is second part. Now for first part, x bar is summation ax upon summation a and y bar is summation ay upon summation a. By these two relations we calculate the x bar and y bar coordinates of the centroid of this figure. So for x bar is a1x1 plus a2x2 upon a1 plus a2. So for this a1 is, so in this figure this part 1 is from here to here and this total is 60. So the remaining is 50 millimeter. So this will be 50 millimeter. So A1 is 15 to 10. So this 15 to 10 and A2 is this 100 into 10. And for X1 and X2. For X1 this will be 25 plus 10. 25 is this half and plus 10. So this X1 is 35 and X2 is, and this X2 is half of this 10. So this is equal to 5 and Y1 is for this 5 and this Y2 is half of this 50. So we will find X bar and Y bar. So on calculating the values, X bar is equal to A1x1, so 50 into 10 into 35 A1x1 plus A2x2, this is 100 into 10 into 5 A2x2 divided by A1. A1 is 15 to 10 plus 100 into 10. So by this X bar is equal to 15 millimeter. On calculating, X bar is 15 millimeter and Y bar is A1Y1. So A1Y1 is 15 to 10 into 5 and plus A2Y2. A2 is 100 into 10 into Y2 is 50. So this is 100 into 10 into 50 divided by A1 plus A2. So this will come out 35 millimeter. So this X bar is 15 millimeter and Y bar is 35 millimeter. So in this figure, we can say that the centroid will lie about this place. So this is Y bar 35 millimeter and this will be X bar. This is 15 millimeter. So this is 15 millimeter X bar and this Y bar is 35 millimeter. Now we find the moment of inertia about this X axis. This X axis, this will be Ixx is equal to Ixx1 plus Ixx2. So now this Ixx1 will be equal to moment of inertia of rectangle 1 about XX by applying parallel axis theorem. So this will be equal to BD cube upon 12 plus area into Y bar minus Y1 का whole square. So this will be equal to as Ixx1 is equal to B into D का cube. So D is the side perpendicular to XX. So in this one part, D is this one and B is 50. So D is this one because it is perpendicular to XX. So here BD cube, B is 50 into 10 का cube upon 12 plus 15 to 10. This is area and multiplied by Y bar is 35 minus Y1. Y1 is 5. So this Y1 is 5 whole square and similarly Ixx2. This will be equal to for second part. So here vertical side is 100 and horizontal side is 10. So 10 into 100 का cube divided by 12 plus 10 into 100 area and this will be equal to 35 minus Y bar minus Y2. Y2 is 50 the square. So this will give you on calculating, this will give Ixx1 and this will give Ixx2. So on calculating, this is 50 into 10 का cube divided by 12 plus within bracket 10 into 50 into within bracket 35 minus 5 का square is equal to 454.166.67. This is IXX1. Now IXX2. For IXX2, 10 into 100 cube divided by 12 plus 10 into 100 into 35 minus 50 square is equal to 1058 triple three 0.33. So now this IXX will be equal to, on adding these, plus 454,166.67. So this will give 15,125,000.003 mm to the power 4. So this is IXX1. Now similarly we can find out IYY. This IYY also equal to IYY1 plus IYY2. So here we are also requiring the use of parallel axis theorem. For this IYY1 is equal to now dB cube upon 12 plus area, and this is x bar minus x1 ka whole square. So by this we can find out IY1, and this will be equal to dB cube. So this 10 into 50 ka cube divided by 12 plus 10 into 50, and this x bar is 15 and x1 is minus 35. X bar is 15 and this x1 is 35, so whole square of this, and this IYY2 will be equal to again dB cube upon 12. So for this dB cube 100 into 10 ka cube divided by 12 plus 100 into 10, this is the area, and this will be equal to x bar minus x2 ka whole square. So by calculating this we can find out IYY. So on calculating, this will be equal to 10 into 50 ka cube divided by 12 plus within bracket 10 into 50 into 15 minus 35 bracket closed square. This is equal to 304 166.67, and this will be equal to as, for this again calculating, 100 into 10 ka cube divide by 12 plus 100 into 10 into 15 minus 5 the square is equal to, this is equal to 108,333.33. So on adding I y y, so this is equal to plus 304,166.67. So this will be equal to 412,500.003. So this is equal to I y y. So like this, by applying parallel axis theorem for both x and for both y. This is y. By applying parallel axis theorem, we can find out the answers. This is ixx and this is iyy. Okay, thank you. Now in this question, we have to find the moment of inertia of this shaded area. About centroidal axis. Moment of inertia of this shaded area. So first of all, we have to calculate the centroid of this shaded area. So for this, we will choose the reference line. So first reference line is this along x-axis, and second reference line is, we have selected this along y-axis. So first reference line is this and second reference line is this, and from this we divide this figure like this from here. So this is one rectangle and this is other rectangle. So for this rectangle, this side is 10 minus 3 is equal to 7 centimeter. So for this rectangle is 3 by 7 and this rectangle of 10 by 3. So this is 1, this is 2, and this quadrant is deducted from this area. So now we will find the centroid. So for this centroid, x bar is equal to a1x1 plus a2x2 minus a3x3, because this is deducted, 3 is deducted. So a1x1 plus a2x2 minus a3x3 upon a1 plus a2 minus a3. Similarly, y bar is equal to a1y1 plus a2y2 minus a3y3 upon A1 plus A2 minus A3. So for this, first of all, A1 is 10 into 3. 10 into 3. So A1 is 10 into 3. A2 is 3 into 7. 3 into 7. And this A3 is pi r square by 4 because it is a quadrant. So this is pi into 2 pi square divided by 4. So this is A1, A2 and A3. Now X1, X2, X3. So X1 is from YY axis. So from Y axis, X1 is, this is total part 1. So for this is 10 by 2. So X1 is 5. X2 is, this side is 3. So X2 is 3 by 2. So it is 1.5. And for X3, so this is a quadrant. So for a quadrant, X is 4r by 3 pi. So 4 into r by 3 pi. So this is X3. Now Y1, Y2 and Y3. So for Y1 is from x-axis. So this is 3y2 for Y1. So 1.5, and Y2 is from here, it is 7 by 2. So 3.5 from here plus 3, this 3 from 3 plus 3.5. So it is equal to 6.5 Y2. Y2 is 6.5 and Y3 is also 4r by 3 pi. So this is equal to 4r by 3 pi. So these are the values. Now on putting x bar is equal to A1 x1 plus A2 into x2 minus A3 into x3. x3 is 4r by 3 pi divided by A1 plus A2 minus A3. So this is, now this y bar is equal to A1 into y1 plus A2 into y2 minus A3 into y3 is similar divided by this A1 plus A2 minus IR square by 4. So we can calculate and find it. So we calculate these value x bar and y bar. Now on calculating, this x bar is with these values 3.303, and similarly y bar is also 3.303. Now to find out its Ixx, so this Ixx will be equal to Ixx1 plus Ixx2 minus Ixx3, because this 3 part is deducted, so this will be minus Ixx3. Now Ixx1 is equal to BD cube upon 12 plus area into y bar minus y1 का whole square. So Ixx1 is BD cube. So the perpendicular side about x-axis is 3, and this is 10 into 3 का cube divided by 12 plus 10 into 3 is the area, and y bar is 3.303 minus y1. So this y1 is 1.5 का whole square. Now similarly Ixx2 is rectangle of 3 by 7. 2 is the rectangle of 3 by 7, and 7 is the perpendicular side about y-axis, about x-axis, about x-axis. So BDQ, B is 3 into 7 का cube divided by 12 plus 3 into 7, and this is 3.303 minus y2. y2 is 6.5 का whole square. Similarly Ixx3, now this is for quadrant. So for quadrant, the moment of inertia of a quadrant about its own centroidal axis is 0.055 r to the power 4. So r is 2 to the power 4. Now plus pi r square divided by 4 is the area, and this y bar is 3.03 minus y3. y3 is 4r by 3 pi. So this 4r by 3 pi, this whole square. So on calculating this, we can find out Ixx1, Ixx2 and Ixx3. And on calculating these values, by putting in this equation, we can find out the Ixx. Similarly, Iyy, this will be equal to Iy1 plus Iyy2 plus minus Iyy3, because 3 part is deducted. So this Iy1 will be equal to dB cube upon 12 plus area into x bar minus x1 whole square. So this will be equal to Iy1 and this will be equal to dB cube. So now interchange the sides. So 3 into 10 ka cube divided by 12 plus 3 into 10 area and this x1 is similar 3.303 and minus x1. x1 is 5. So this x1 is 5 whole square. Now IY1, this is equal to 7 into 3 का cube divided by 12 plus 7 into 3, and this is 3.303 minus x2. x2 is also 1.5. So this is whole square. Now IY3. Now for quadrant, again this is 0.055 into r to the power 4. This is the moment of inertia of a quadrant about its own centroidal axis, plus pi r square divided by 4 into 3.303 minus x bar minus x3. x3 is also 4r by 3 pi. So this is equal to this. So on calculating, we can find out the values. So now on calculating, we can find out the values. Now on calculating, this IXX1 is 120.024. This IXX2 is 300.386 and IXX3 is 19.801. And on putting these three values in this equation, IXX1 plus IXX2 minus IXX3, this is 120.024 plus 300.386 and minus this IXX3, this will give the value 400.609 centimeter to the power 4. Similarly, on calculating this, IYY1 is 336.394 and this IYY2 is 84.017 and this IYY3 is similar 19.801. So on putting this in this equation, IY1 plus IYY2 minus IYY3, this IYY is equal to 336.394 plus 84.017 minus 19.801. So this will give the value 400.61 centimeter to the power 4. So both IXX1 and IXX2 are similar for this figure for moment of inertia about centroidal axis. Okay, these are the values. Thank you.